Biomechanics is simply the physical discipline of mechanics as it applies to living things. Before we get to that point, however, we need to understand a few things about mechanics in general. We need to be able to speak the language of mechanics, including coming to grips with core principles like force, energy and work, and power. We also need to be able to quantify these things in a way that everyone understands. And this means we need to be conversant with the units in which these things are expressed. There's a standard scientific system for doing this, and we need to be familiar with that and to abide by it. For mechanics, there's a fundamental distinction between stress and strain. These terms are often used carelessly and interchangeably, but this only opens the door to incoherency. The words stress and strain have very specific meanings in mechanics. Keeping the distinction straight opens the door to a variety of tools that help us gain a very powerful understanding of mechanics. There are other important terms that have very specific meanings, core terms like elasticity, and perhaps more importantly for living things, what non-elastic materials are. We'll be exploring that as well. As you watch the lectures to follow, I want you to keep four things in mind. First, what is the precise meaning of terms like force, work, and power? Second, and related, how do we express these properties in the proper units, which for modern scientific discourse is the SI units? Third, what are the specific meanings of stress and strain, and how can these be analyzed using the stress-strain curve? Fourth, and finally, what is the specific meaning of elasticity, and what does it mean for a material to be non-elastic?